If you want to know the basics of artificial intelligence but don't have a technical background, stick around. I've just spent several hours going through some of Google's beginner-friendly AI courses, and I'm about to share my key takeaways I learned to help you get started with AI today. Hi, I'm Patrick, and if you're over 40 and suspect that your toaster might be smarter than you by now, this channel is for you. I started AI for grown-ups because AI is changing everything. How we work, how we run our businesses, and how we talk to each other. But most AI content here on YouTube is made for younger audiences and tech-savvy people. My goal is to help people like us understand and use AI in simple, practical ways. In this video, we will break down AI, what it is, how it works, and how you can start using it to make your life easier. So let's get started, and be sure to stick around until the end. I will be sharing the #1 AI tool that has changed the way I work over the past year. Let's start with the big one. What is artificial intelligence really? AI is a broad field of study, like math, science, or history. Just like how people study biology to understand how living things work, or study physics to understand how the world moves, people study artificial intelligence to understand how to make computers smart. AI combines knowledge from math, computer science, and even psychology. AI is software that can think and learn like a human. It analyzes information, predicts trends, and creates content. Just as algebra is a subfield of math, machine learning is a subfield of AI. And if we go down one more level, deep learning is a subset of machine learning. Deep learning models can further be broken down into discriminative models, generative models, and large language models, or LLMs. ChatGPT or Google Gemini are created by combining a large language model that understands language with generative AI that creates new responses so that it can talk, assist, and write like a human. So now that we have an understanding of what AI is and how those elements sit in relationship to each other, let's learn more about each level. The simplest way to think about machine learning is when a computer uses data to train a model. That trained model can then make predictions on new data it has never seen before. For example, if you train a model by giving it lots of pictures of cats and dogs and it learns how to tell the difference, you can then show it a completely new picture and it will be able to predict if it's a cat or a dog. The most common types of machine learning models are supervised and unsupervised learning models. Supervised learning uses labeled data to train models, while unsupervised learning finds natural groupings and patterns in unlabeled data. In this supervised learning model example, we want to train a model to classify emails as spam or not spam. To do that, we feed the model with labeled data, i.e. emails that are already tagged as spam or not spam. The model learns patterns like certain keywords, sender behavior, etc. that distinguish spam from regular emails. Using a supervised learning model, we can now predict if a new email is spam or not spam. For the unsupervised learning model, we look at the raw data and see if it naturally falls into groups or patterns. To demonstrate this, we look at a pile of mixed Lego blocks in different colors, shapes, and sizes. But don't tell the system how to group them, and all the Lego blocks are unlabeled. If they were labeled, we would see the size, shapes, and colors. The system now looks at the blocks and notices similarities, like which ones are in the same shape or color. It starts to group them into clusters, maybe all the square pieces in one group and all the red blocks in another group. Even with a simple task like sorting Lego, you can see how unsupervised learning helps a system make sense of raw, unlabeled data and use it to make smart decisions moving forward. So now that we know what machine learning is, let's talk about deep learning. Imagine your brain. When you learn something new, like recognizing a friend's face or understanding a new word, your brain forms connections. These connections help you make sense of the world around you. Now, instead of a brain, deep learning uses something called artificial neural networks. These are computer systems that are designed to work in a similar way to how our brain works, with layers of connections between neurons. The more layers they have, the deeper the network, which is where the term deep learning comes from. Because deep learning uses neural networks, we can now do something called semi-supervised learning, which is a combination of both supervised and unsupervised learning. It means a deep learning model is trained on a small amount of labeled data and a much larger amount of unlabeled data. For example, a hotel company might use deep learning models to categorize customer reviews. The hotel company spends a bit of time to tag or label 5% of their reviews as either positive or negative. The small labeled portion serves as the guide, while the remaining 95% of reviews stays unlabeled because they might not have the time or resources to label all reviews. The deep learning model then analyzes the rest of the unlabeled reviews using patterns it learned from the labeled ones. For example, if it sees phrases like fast delivery or very helpful in reviews that are labeled as positive, it looks for similar patterns in the unlabeled ones to determine which ones are positive. Likewise, if it sees phrases like unfriendly staff or dirty room in the reviews labeled as negative, it looks for similar patterns in the unlabeled ones to determine which ones are negative. This approach saves time, as labeling data can be time-consuming and expensive, especially when there's a lot of it. Now that we have an overall understanding of deep learning, let's look at the next layer of it, which divides it into discriminative and generative models. A discriminative model is a type of machine learning model that focuses on distinguishing between different labels of data points and only has the capacity to classify those data points, such as positive versus negative. For example, let's say we have pictures or data points of different cakes. We purposely label some of them as chocolate cake and some as fruit cake. The discriminative model will learn from the label chocolate cake or fruit cake. And if you give it another picture of a fruit cake, it will predict the label for that new data point, a fruit cake. Unlike discriminative learning models, generative models learn to understand how the data is created. Instead of just learning the difference between classes or labels, a generative model learns to generate new data that looks like the data it has been trained on. Going back to our cake examples, the pictures or data points are not labeled as chocolate cake or fruit cake. So a generative model would learn to create a new picture based on the patterns it just learned. Like these data points have fruit pieces as decorative toppings, have fruit layers, and light colored spun layers. So when we ask a generative model to create a picture of a fruit cake, that model generates a completely new pictures of a fruit cake based on the patterns it just learned. Let's now look at different generative AI model types. First off are text-to-text models like ChatGPT and Google Gemini. Another one is text to image like Midjourney, DALL-E, or Stable Diffusion. And as the model type suggests, those can create and edit images. Text to video models can generate and edit video footage. Some common ones are Google's Image Gen Video, Pika Labs, or Lumin 5. Text to music models are used to generate original music and lyrics. One of the most well-known examples is Suno. And finally, text to code models are able to write and complete code. Two examples are GitHub Copilot and Tab9. We will use many of those generative AI models in future videos, so stay tuned. Now would also be a good time to hit that subscribe button and give this video a like. And finally, let's talk about large language models, or LLMs. LLMs fall under the broader category of deep learning. And while they share some common ground with generative AI, the two are not identical. Large language models focus specifically on understanding and generating human language. Large language models are pre-trained on large amounts of text data and are capable of producing highly sophisticated text-based outputs by being fine-tuned for a specific purpose. Let's look at an example demonstrating this concept. Imagine you are training to become a professional athlete. You start by learning and practicing general fitness like running, coordination, strength training, and agility. Your reward will be overall or general fitness. This is like the model learning the general structure and rules of language as part of the pre-training. Now, suppose you decide to specialize in soccer or tennis. You start specific training like practicing passing, dribbling, or serving, footwork, and other essential techniques. You're essentially fine-tuning your abilities to excel in your chosen sport. The same idea applies to large language models. The pre-training provides the LLM with a general education before it learns to do specific tasks. In this stage, the model learns about the language itself, so it is able to solve common problems like text classification, question answering, document summarization, and text generation. At the end of the pre-training, the model has a general understanding of language, but it's not yet specialized in any particular task. Fine-tuning is like giving the LLM specialized lessons on a specific task using smaller, more specific data sets. It takes the general knowledge learned during pre-training and refines it to make the model better at a specific job. After pre-training, the model is fine-tuned by exposing it to smaller, industry-specific data sets to solve problems in industries like healthcare, finance and banking, retail and e-commerce, and media and entertainment, to name a few. During fine-tuning, the model is trained to focus on understanding and generating text that is relevant to the specific task, like answering medical questions or writing technical reports. This creates a win-win situation as large corporations invest billions in developing general-purpose large language models, which they can then offer to smaller organizations like real estate businesses, banks, and hospitals. So now that we have covered the building blocks of AI, you might be wondering, okay, but how does this actually help me? That's where things get exciting, because one particular tool built on everything we've just talked about has really changed the way I work, create, and solve problems. You might have guessed it by now, it's ChatGPT. Here are 3 simple ways I personally use ChatGPT almost every day. The number 1 way is for writing and communication. As you probably know, communication is key in business, whether it's putting together a presentation, drafting an important email, or just brainstorming ideas for new promotions and events. I can simply type something like, write me a welcome speech for our annual staff party, and within a second, it gives me a clear, well-worded draft that I can fine-tune in my own voice. Even little things like replying to emails, writing captions for social media posts, it's great to have a tool that helps you organize your thoughts quickly and professionally. I probably save a couple of hours each week having ChatGPT as my trusted writing assistant. The second way I use ChatGPT is for brainstorming and problem solving. Whenever I get stuck, whether it's coming up with the content ideas, solving a customer's issue, or figuring out how to simplify a complex topic, ChatGPT is my go-to tool. I treat it like a creative partner. I ask questions, throw out ideas, and it helps me think through options I hadn't even considered. For example, if I want to come up with new promotions for our Japanese restaurant, I type something like, give me 5 creative dining promos for a resort-based Japanese restaurant that would appeal to couples and foodies. Within seconds, I get recommendations like sunset sushi and sake pairing, chef's table omakase night, or a weekend ramen and jazz brunch. It even helps me refine the concept by adding taglines or describing how to present the experience. Another way I'm using ChatGPT that I wanted to share with you today is for learning and research. One of the biggest surprises for me when I started using ChatGPT was how much easier it made learning. Instead of opening a dozen browser tabs, scanning articles and trying to figure out which YouTube videos explain something the best way, I just asked ChatGPT directly. Whether I want a summary of a business book, a quick refresher on hospitality trend, or help understanding a technical term I keep hearing, ChatGPT gives me fast, straightforward answers in plain English. Let's say I've been hearing a lot about revenue management in the hospitality industry, and I want to explain it simply to one of our new staff members who's not from a hotel background. I could prompt by typing explain hotel revenue management to a new staff member in simple terms. In just a few seconds, ChatGPT gives me a clear explanation, no complicated formulas, just the key idea that it's about selling the right room to the right guest at the right time for the right price. I could then take it and use it in a staff orientation or a training slide. There you have it. AI doesn't have to be intimidating. Tools like ChatGPT are already making life easier, and you don't need a tech background to start. If you're over 40 and want to learn AI in a simple, practical way, this channel is for you. Thanks for watching, and remember, you're not late to the AI party, you're right on time. See you in the next one.